Let us discuss insertion sort with an example. For that, we will consider an array of 5 elements: 36, 16, 4, 22, and 100. These elements are available in array positions 0, 1, 2, 3, and 4. Insertion sort is done by inserting each key at its appropriate position by comparing it with its sorted sublist of predecessors. Let us try to understand this with the steps involved in the algorithm. So as the step number 1, we will be fixing the first key 36, that is A of 0, we will be fixing it, and the remaining keys 16, 4, 22, 1 we have to insert in the correct position. That means for 5 keys we have to insert 4 keys. In general, for n keys we have to insert n minus 1 keys. In every pass we'll be inserting this n minus 1 keys. So as the first statement in the algorithm, we have for I equal to 1, I less than n, I plus plus. That means the for loop runs for I equal to 1, 2, 3, and 4 when n equal to 5. So now we have to insert the keys a of 1, a of 2, a of 3, and a of 4. When I equal to 1, we'll be inserting a of 1. When I equal to 2, we'll be inserting a of 2. When I equal to 3, we'll be inserting a of 3. And when I equal to 4, we'll be inserting a of 4. So we are using a variable key equal to a of I. That means when I equal to 1, key will be a of 1, and so on. So now we have to insert at the correct positions 1, 2, 3, 4. So let us have a variable position equal to I. So when the for loop runs for 1, 2, 3, 4, the position will take the values 1, 2, 3, and 4. So now in the next step, in order to insert the key, we have to repeatedly compare with its sorted predecessors. That means when I equal to 1, we have to compare with the key a of 0. When I equal to 2, we have to compare with a of 1 as well as a of 0. When I equal to 3, we have to compare with a of 2, a of 1, a of 0. When I equal to 4, we have to compare with a of 3, a of 2, a of 1, and a of 0. This is a repeated process. Hence, we will use a while statement as follows. While first condition, as of now, we will leave it blank. And the second condition is a of position minus 1 is greater than key. That means when the condition a of position minus 1 greater than key is true, then we have to insert the key at position by using the following statements. That is a of position equal to a of position minus 1. Then we decrement the position, which is position equal to position minus 1. Then we have to assign the value key to its correct position, which is a of position. From our example, we have 36, 16, 4, 22, 100. When I equal to 1, position equal to 1. Similarly, key equal to a of 1, which is 16. So we have to compare a of position minus 1, which is a of 0, with the key. Or in other words, we will be comparing 36 greater than 16. So 36 greater than 16 is satisfied. That means the correct position of 36 is position actually, but 36 is already in position minus 1. Therefore, we have to assign the statement a of position equal to a of position minus 1, or in other words, a of 1 should be equal to a of 0. That means our array status will be a of 0 is 36, a of 1 is 36. So now the correct position of key is at actually position minus 1. So now we will assign the key to position minus 1 by decrementing the position as position equal to position minus 1 and inserting the key at position as a of position equal to key. So now the array status will become 16, 36, 4, 22, 100. We can see that the first two elements 16, 36 are now in sorted. The remaining three elements 4, 22, 100 are to be inserted at the correct position by repeating the process. So summarizing the algorithm, we have for I equal to 1, I less than n, we have key equal to a of I, position equal to I, while still the first condition in the while statement is blank. and position minus 1 greater than key means we have to do all these things. So now in order to fill the blank, we observe that we decrement position inside the while loop. Hence, position should be greater than 0 because when position equal to 0, if we decrement position, we will get position equal to minus 1. Hence, position should be greater than 0. So now the while condition first statement should be position greater than 0 and a of position minus 1 greater than key. This is what the insertion algorithm does. So now we observe that when the input is in already sorted order, that is already the input is in the ascending order, then the insertion sort every pass will take one comparison, and hence in the best case the time complexity of insertion sort is O of n. But in the worst case or in the average case, the insertion sort takes O of n square time.